Okay, so let's look at the first page of the Chapter 1 test. Um, and we went over this in class, but not everyone was there. So the first part is you have to make a quick sketch of these 5 functions. So x cubed, most people got this all right. So x cubed looks like this. Root x starts at 0, 0, and then increases kind of like that. 1 over x has the two parts that look like this. Ln of x starts out at 0 but never actually reaches 0, and it goes upwards like this. It's got an asymptote, a vertical asymptote at 0. And cosine x starts at 1, and then it kind of cycles around like this. Okay. So then in number 2 it says which of the following are odd functions. So odd functions are symmetric about the origin, which is the same thing as saying if you put your finger at the origin and spin the page 180 degrees, the resulting function looks exactly the same. So the ones that fit that are A and C. Okay, there are no other functions. The cosine looks like it's an even function, but it's not odd. Okay, has a horizontal asymptote. This one confused a lot of people because a horizontal asymptote talks about what happens at the ends of the graph. So some people thought that cosine has a horizontal asymptote of 1 and -1, but those aren't asymptotes because a horizontal asymptote is asking what happens out at infinity. What happens to the function? Does it equal a specific value? Okay, so if it doesn't equal a specific value, then it's not an asymptote out at infinity. Cosine keeps bouncing. If I said, what does cosine get close to out at infinity? It doesn't get close to anything. It keeps bouncing back and forth between 1 and -1. So it has no horizontal asymptote. The only one here that has a horizontal asymptote is C. Some people were wondering about B, why this one doesn't have a horizontal asymptote. And in B, on the right side here, it keeps increasing to infinity. So it doesn't have a horizontal asymptote on the right side. And on the left side, you would want to check, well, what's the limit as x goes to -infinity of f of x? And there are no values for -infinity. So it doesn't have a horizontal asymptote over on the left side either. Okay, so that's B. C says, what's the limit as x goes to 0 from the right side of the function f of x? And so when I say that, I'm saying we're looking at what happens to a function as I come this direction towards 0 from the right side of 0. And this says that it equals -infinity, so this would mean wherever I'm coming from, I'm going to have to shoot down towards -infinity somehow. So there's only one graph that does that, and that's D. Unbounded confused a lot of people. Unbounded means that, let me zoom out a little bit. Oh, that's an awful lot. Unbounded means that it's either not bounded above or not bounded below, or not bounded either way. It could be both, right? Not bounded above and not bounded below, right? Now, most people are comfortable with this definition, but didn't realize that not bounded above means unbounded, or just not bounded below means unbounded. So like if I draw a graph that looks like this, even though it's bounded above, you would still say the whole graph is unbounded. Okay, so in this case, the unbounded ones, the ones that go up to infinity or down to -infinity or both, those are going to be, here, let me clear this out so it's not in the way. Where's the x? There it is. So those functions that go, that are unbounded either above or below, so they're just called unbounded, that's A. B keeps going up to infinity, so that's considered unbounded. C goes up to infinity and down to negative infinity, so that's unbounded. D does both as well. E is the only one that's bounded because it's bounded both above and below. Then this last one, increasing throughout the interval 0, which is included, so it's got a bracket, to infinity. So A is definitely always increasing, and it's definitely increasing from 0 up to infinity. B is also doing the same thing. And then a lot of people were wondering about D. But D, if you look at it, D is always increasing, but it never actually starts at 0, right? So D is increasing on the domain, on the interval 0 to infinity, where 0 is not included, but it doesn't exist at 0 with the bracket. It doesn't exist at x equals 0, so you would say that it's not actually increasing or decreasing there. It's doing nothing there. So D doesn't count, just A and B.